Dear students, in the last lecture, that is in lecture 3rd, I think, we have discussed the correlation topic. In this chapter, in this lecture, we will study the regression analysis and curve of regression. So let us see the term regression, how it was invented, and what is the uh, basic thing regarding regression and all. The term regression was first used by Sir Francis Galton, a British biometrician, in connection with the height of parents and their offsprings. He found that offsprings of tall or short parents tend to regress to the average height. In other words, though tall fathers do tend to have tall sons, yet the average height of tall fathers is more than the average height of their sons, and the average height of short fathers is less than the average height of their sons. The term regression stands for some sort of functional relationship between two or more related variables. The only fundamental difference, if any, between problems of curve fitting and regression is that in regression, any of the variables may be considered as independent or dependent, while in curve fitting, one variable cannot be dependent. Regression measures the nature and extent of correlation. Regression is the estimation or prediction of unknown values of one variable from known values of another variable. Now you see the regression and curve of regression. Regression analysis is the method used for estimating the unknown values of one variable corresponding to the known values of another variable. When a number of pairs of two correlated variates are plotted on a graph paper, then the scattered diagram is concentrated around a curve. The curve is called the curve of regression, and the relationship is given by curvilinear regression. The equation of the regression curve is said to be regression equation. Now see line of regression, what it is. Let the number of pairs of two correlated variables be x1 y1, x2 y2, x3 y3 dot dot x and yn. Suppose we have to find out the unknown values of y for a certain value of x. Then we have line of regression of y on x, that is y is equal to a plus bx. If we have to find out unknown values of x for a given value of y, then we have a line of regression of x on y, that is x is equal to a plus by. So we have two lines of regression. When the curve is a straight line, it is called line of regression. Regression will be called nonlinear if there exists a relationship other than a straight line between the variables under consideration. Now see equations to the lines of regression. This is xy, x-axis, y-axis. Let y is equal to a plus bx be the equation of the line of regression of y on x. Let x r, y r, this one be any point of the dot. PR equals to yr, this one. QR equals to a plus br, and PQ is equal to PR minus QR. So YR is equal to minus PQ is equal to YR minus A minus BXR. Let S be the sum of the squares of such distances, then S is equal to summation Y minus A minus BX whole square, according to the principle of least squares, which I have already studied in the last lecture also. I have also given the video for this one. We have to choose A and B so that S is minimum. The method of least squares gives the condition for minimum value of S. In this way, while calculating del S by del A, del S by del A and all, finally we get this is the equation. This equation which satisfies x bar y bar lie on the line of regression 1. We're shifting to this equation, putting these values here, final equation we get. From here we can get slope of the line of regression, that is b is equal to r sigma y by x. This is called slope of the line of regression. When line of regression y on x on y, this one is r, x on y is r sigma x upon sigma y. They see here similarly the regression line of x on y is b by x. This is x on y and this is y on x. Alright, so bxy is equal to r sigma x upon sigma y. See from here just because del s by del a is equal to this much and del s by del must be 0, so from here we get, for s to be minimum, sigma y minus a minus b equals to 0. Sigma y equals to this one, and again you will find from sigma del s by del b this equation, that is sigma xy equals to a sigma x plus b sigma x square. These two equations you have already studied in the car fitting also. These are normal equations. From here what you have to do, you just multiply throughout by n. So here you will get sigma y by n, there here equals to a plus b sigma x by n. And what is this? Sigma y by n is y bar equals to a plus b sigma, this is x bar, and this is x bar y bar are mean of x and y respectively. Alright, therefore x bar y bar lie on the line of regression 1, shifting origin to xy, then the equation 3 becomes, now you are shifting the origin to xy, so the equation 3 becomes, this is your equation 3. So summation x minus x bar, here I am writing instead of x I am writing x minus x bar, and y instead of writing y minus y bar, equals to, we get here a summation x minus x bar plus b summation x minus x bar whole square upon nothing, not 10. So b equals to, because this becomes 0, this becomes 0, from the above you can see this, from here only it becomes 0. So we know that b equals to this much, but we also know that r equals to summation xy upon n sigma x sigma y, or sigma xy is equal to this, from here only you can get. So instead of writing sigma xy, you can write from here b sigma x square is equal to n r sigma x sigma y, and from calculating from here you can find r sigma by sigma x, that is slope of the line of regression we will denote as b equals to r sigma y by sigma x. The line of regression passes through x bar y bar, hence the equation of the line of regression is y on x, so y minus y bar equals to r sigma y by sigma x, x minus x bar. Similarly, the regression line of x on y is given by x minus x bar is equal to r sigma x by sigma y, here y minus y bar, and this by, since y on x, that is so you can write byx equals to r sigma y by sigma x, and here be x on y, so bxy equals to r sigma x by sigma y, are also known as coefficient of regression. If you multiply these two coefficient of regression, you will get r square. Now you solve one problem based on this. From the data given, find the equation of line of regression of x on y and y on x both. Also calculate the correlation coefficient. See the data here. Data is given x 2, 4, 6, 8, 10, y has the value 5, 7, 9, 8, 11. Number of values n equals to 5, see 1, 2, 3, 4, 5. X bar you will get x summation x by n, summation x you just add this and divide by 5, you will get 6. Y bar, how will you get? You just sum it. See there, here it is written x has value written here, y is written here, x minus x, capital X is equal to x minus x bar is written here, capital Y is equal to y minus y bar is written here, capital X into capital Y is written, capital X into capital Y whole square both has written over here. So what you have to do, just find the values. So here you can see capital X has x minus x, y has y minus 8, x, y. I have written the table over here. Coefficient of correlation R, I have written one formula, capital R or small r equals to summation x y upon under root sigma x square into under root sigma y square. Sigma x y has the value, what it is, 26. Sigma x square is 20. See here, sigma x square, this one is 40 and sigma is y square is 20. Multiply here and write, you will get the coefficient of correlation as 0.9192 and R has the value 0.65. See from here, because R sigma y by sigma x is equal to R sigma y square has the value 40. No, that is 20 and sigma x square is 40. When calculating you get here 0.65. Slope of the line of regression y on x, you have got 0.65. You just put it there. So equation of line of regression y on x is given as y minus y bar equals to R sigma y by sigma x, x minus x bar. Here also you have to find out R sigma x by sigma y, because line of regression of x on y, this is slope is 1.3. So y minus y bar is the value 8, you write just here, and this has value 0.65 which is written over here, x minus x bar is 6. By simplifying you get 0.65 x minus 4.1. And equation of the line of regression of x on y is x minus x bar, x is equal to x sigma x by sigma y minus y bar. After just putting these values, you will get x minus 1.3 y equals to minus 4.4. So this is way to find the coefficient of correlation. Coefficient of correlation is not you have to find, we have to find line of regression on x of x on y or y on x. So in this way, this is also one question you can will try to solve. Find the coefficient of correlation and regression lines of following table. See x, y, x has value 5, 7, 8, 9, 11, 13, 16, y has value 33, 30, 28, 20, 18, 16, 9. So from the above process you can try to find R coefficient of correlation as value minus 0.9868, y on x as line of regression, y is equal to minus 2.273x plus 44.738, and x on y is equal to x plus 0.42834 equals to 19.4226. So these are some more questions you try to solve by yourself and do. Now we'll discuss a little bit more multiple regression. What is multiple regression? Just see, multiple regression, we know that production of what wheat depends not only on the amount of rainfall x1 but also on the pesticide fertilizers x2, pesticides x3, quality of seeds x4, quantity of soil x5, etc. In a multiple regression, the dependent variable is a function of more than one independent variable, isn't it? So line of regression is a linear relationship between y and x1, x2, x3 dot dot etc. And this can be put as y equals to a naught plus a1 x1 plus a2 x2 plus a3 x3 plus dot dot dot. In multiple non-linear regression, equation is not linear. For example, see, this is one question. So this is one question. Okay, so we'll discuss the problem based on this one in the next lecture. Thank you so much.